Hello all. So I welcome you to this lecture. Today we are going to talk about an aspect of research, very important aspect, and that is hypothesis formulation. So today's topic is hypothesis formulation and testing. We want to discuss the importance of formulating a hypothesis and testing it in research. Now, hypothesis is a kind of guess. You're trying to guess what the outcome of a research should be in the scientific way. So that guess you make in the scientific way is called hypothesis. Now, whether you are carrying out a quantitative or qualitative research, it requires that you formulate a hypothesis. And then that is what we address your research problem or research question. Now, when you've gathered data, you need to, examine the data, analyze it scientifically, and then decide on what you have. Make, an inference from the data in the scientific way. This is what is required in research. Now, remember, the scientific method involves these 6 steps. Scientific method involves 6 steps as follows. 1, asking a question. Why will you ask a question? You can ask a question because you have observed something. You have observed the world around you, and you want to know what is taking place. You want to find out what actually is the situation. So you need to ask a question about that. Now, after asking the question, the next thing to do is to research existing sources of information. And this can actually be carried out, by, literature review, studying literature of issues surrounding the questions that you have raised, and also gathering data, gathering information about the question so that you can be able to, look into the situation and find out what is actually taking place. Now, when you have gathered data, you need to, before even you gather your data, you need to formulate a hypothesis. That is, you want to talk about possible, situation in this, study. That is what we mean by hypothesis. You want to guess what could this situation be like. Now, usually we have hypotheses that support what you believe as a researcher in the data you have at hand, what you think should be happening. So you have a hypothesis that favors that. And then you have a hypothesis that runs contrary to that, that is opposing what you think should happen. That's another hypothesis. So at least you must have 2 hypotheses, one in favor and one against your feeling or your understanding, on the surface of the data you have before you. Now, after formulating a hypothesis, you need to design and conduct the study per se. Design how the study will go about, how you go about, gathering the data and then researching it, finding out the information. You need to design that and conduct the study per se. Then, after that, is to analyze the data and then draw conclusions. Analyze the data, the data you are analyzing is based on the hypothesis you have formulated. So you use the scientific way to actually carry out the analysis and then make a conclusion about it. Then the last part is to report the results. To make a report of what you have found out, your findings, you have to make it known to the external world by means of your reports. All right. So those are the 6 steps involved in the scientific method of research. So when you have data, even when your data merely looking at it is pointing towards that direction, you cannot make, a firm conclusion yourself, except you have subjected the data into scientific analysis. And that is what is acceptable. So when you subject it to scientific analysis, then people will be able to accept it. They will be able to accept the results that you have obtained. Otherwise, they will believe that you are speculating. Even though it may be obvious, but merely looking at the data, but you must have a scientific background for supporting what position you are taking. Otherwise, it will be regarded as speculative, conclusion. All right. So now, let us look at how to formulate hypotheses. All right. Hypothesis itself, it's a conjecture, a guess of what you feel is taking place. So in formulating hypothesis, what you are doing is predicting the relationship between variables. You are trying to predict the relationship between variables in your data. So a hypothesis is a tentative conjecture explaining an observation, phenomenon, scientific problem that can be tested by further observation, investigation, or experimentation. Now, a hypothesis can be regarded as a testable explanation of a problem. Testable explanations of a problem, phenomenon, or observation. And that is why we say it's a guess or assumption. It is it's suggested, it's a suggested explanation about relationship between two or more variables. So it is not really valid until it has been subjected to the analytical tests. Then a conclusion can be drawn based on the hypothesis. So as a researcher, before you formulate your hypothesis, first thing to do is to read thoroughly about your topic. Search thoroughly, carry out a thorough literature review about your topic. And then how do you do this? You consult articles, journals, books, cases, all related available information, particularly related to the field where you want to study. All right. There, when you do this, you'll be able to gain you will be able to gain sufficient information about your topic, and that will enable you to narrow, your topic to a particular limit, and that is what we are going to express in your research question. Your research question must reflect, your limits, your scope, where you are actually looking into in the research. Now, the research question is related to the topic of the research. It's related to what you are considering the research. And it can be stated either in one sentence, for instance. And then when you do that, you can consider it as a research hypothesis. So for that reason, sometimes the hypothesis is referred to as the thesis statement. Thesis statement. Or sometimes they say you hypothesize. You hypothesize. So sometimes these terms can be used to refer to hypothesis. You can say it is hypothesized, or it is posited, theorized, or proposed. So look at all these terms. They are, expressing the term hypothesis. And you will also see that when you say posited, you are taking a position. You are taking a position, or you theorize. You are just formulating a theory. The theory can be confirmed or refuted at the end of the research. Or you propose. When you propose something, it not necessarily mean that is what is going to take place. At the end of the research, you'll find out what actually will take place. All right. Now, for the hypothesis to be useful, it must be scientific, and statistical, like we said. Scientific method is what is acceptable in research. You don't just merely look at a group of data and then, make a conclusion. The conclusion has to be based on the scientific method and statistical analysis. But we want to realize that formulating hypotheses will help you to have an initial explanation, initial explanation on the data you have at hand and the research process. And so in formulating a hypothesis, we want to, follow these steps. We want to follow these steps so that we have an idea of how hypotheses should be formulated. All right. So let us see. The first step, A, you want to bear in mind, like I said, that at least you must have two hypotheses, at least two hypotheses. One, as I mentioned, is the one that goes in favor of your opinion. or your observation of the data at hand, the position you wish to take, while the other hypothesis is contrary to that. It goes contrary to what you feel. Now, the hypothesis that goes contrary to what you feel is the first one that is listed here, and that is the null hypothesis. The null hypothesis. Look at it here. We have the null hypothesis represented as H0, H subscript 0. The null hypothesis is the hypothesis that assumes that there is no relationship between variables. The variables does not affect each other. You don't have any, any effects due to one variable from another. That is the null hypothesis. It does not see any, dependability between two variables. It assumes there is no effect. One does not affect the other. Whereas the alternative hypothesis is the hypothesis that you have interest in. You have interest in this one. You observe the data and you assume that this should be the situation of what is taking place in the data set that you have. So that is the alternative hypothesis. Now, what point you are interested in should always be placed in the alternative hypothesis. What you are interested in will be in the alternative hypothesis, because that is the one that shows that there is a relationship between one variable and the other. That is, one has effect on the other, or one is dependent on the other. Now, alternative hypothesis should be the H1, represented is the H1, and that should be what you believe should be taking place. Whereas null hypothesis is the one that assumes there is no effect, no relationship between variables. One does not affect the other. Now, the point B here is what I've just explained. Now, the claim that you wish to test is the alternative hypothesis. That is what you are interested in. What you should observe in your research is what you formulate as the alternative hypothesis. And that shows that statistically, when you check, there will be a significant difference or effects or relationship between two variables or two individual or two events. That is what an alternative hypothesis, indicates. All right. The null hypothesis is contrary to that. Does not see any significant relationship, statistically speaking, between two variables or two groups of variables or two individual or two events. All right. Point number C. The null hypothesis H0 that we call H0 should always include the value in question and should be the complement of the alternative hypothesis. So that means the null hypothesis shows that there's no significant difference between two groups or variables under study. And then it should complement the alternative hypothesis. The two of them must be together to form a complete, complete statement about the research. So it should include the value in question. When you are dealing with numerical value, the null hypothesis should have the value in question with it. Now, as you are formulating your hypothesis, you will start by assuming that H0 is true. And then you want to try and find evidence statistically in your research analysis that H0 is not true. And that is what you are trying to do, to actually show that your own position, which is H1, is true. So your statistics is geared toward confirming that H0 is not true, but H1 is true. So you will start by assuming that H0 is true. That's an assumption you make at the start, that null hypothesis is true, until you find evidence otherwise that H0 is not true. So you go ahead and then carry out your analysis, your statistical analysis, and come out with the true position. And then the true position may now be that alternative hypothesis is true. So in that case, you will now reject the null hypothesis and accept the alternative. Now, point number E, you have to be sure that each time your hypothesis is clearly understood and defined. When you make your hypothesis, when you formulate your hypothesis, you must make it clear. Make it clear what each hypothesis is representing and the terms are defined. Do not assume that your reader will actually understand. Do not assume that. You need to explicitly, state what each term in the hypothesis indicates, what they mean. And then point number F, you have to bear in mind that your hypothesis may change over time. Yes, we said hypothesis is like guess. So as your research progresses, there may be need to modify your hypothesis or change it, entirely to actually, go in the direction of the research that you are carrying out. So you have to bear that in mind. The hypothesis can change. All right. Now let's briefly talk about significant level and degrees of freedom. After we have learned how to formulate hypothesis, the other aspect that is important in the research is how to, the significant level and degrees of freedom. Level of significance is referred to as confidence level or represented as alpha. Call it alpha level. All right. The alpha level is there are two types of alpha commonly used in research. That is a 5% level. That is 0.05. That is 0.05, 5%, and then 1%, 0.01, 0.05, and then 0.01. Now, in a research, commonly used value is the 5% value in the research. For standard research, unless otherwise stated, 5% is the usual significant level that we employ. Now, when you use 5% in any study, the implication is that if this study is replicated 100 times, you are saying that the results that you are going to get is going to be valid at least 95% times. At least 95% times. And only 5% out of 100 may vary due to some chance in the research. And that is the meaning of a 5% alpha level or 5% confidence level. That is, if the research will be replicated 100 times, the same result will be obtained at least 95 times. And then only 5% will vary. The result of 5% will vary due to some chance. Similarly, when you use 1% confidence level, that is 0.01 alpha, you are saying that if the research is replicated 100 times, 99% will be the same results, while only 1% will vary due to chance factors. Okay, so that is very strict, more strict than the 5%. So that is it. So depending on what research is requesting for, 5% or 1% may be used. Sometimes 10%. Now, that is a significant level or level of significance. That is alpha in the research. This level will be stated usually in the research so that you can carry out your statistics, your analytical statistics to analyze what's the data actually bring out so that you can confirm any of the hypotheses you might have formed. Now, quickly, let me mention that formulating hypothesis does not always mean that we have two hypotheses, but like we have a null hypothesis and the alternative hypothesis. Usually, we must have at least these two in the research. So there must be a null hypothesis and at least one alternative hypothesis. But you may have, you might have more than one alternative hypothesis, depending on the research you are carrying out. You may want to look at differences between several variables, and that may include formulating many more than one alternative hypothesis. But there will be a null hypothesis, at least null hypothesis will stand, and at least one alternative hypothesis. When you have more than one alternative hypothesis, then instead of having only H1, we can have H1, H2, H3, H4, and so on, depending on how many conditions you are testing, how many, relationships, statistical significance you are testing in a particular research. That is that. All right. Now, let's talk about degrees of freedom. Degrees of freedom indicate the number of observations which are free to vary, when certain restrictions have been placed on the data being considered. That is degrees of freedom. degrees of freedom. So that figure 2 will be obtained from the data at hand, and particularly the inferential statistics that you are employing. Each inferential statistics has the way to calculate its own degrees of freedom. Degrees of freedom and the significance level, they are important for you to check values from statistical table. Your statistical table will help you to compare your results with standard values so that you can make an inference and make a final conclusion regarding your hypothesis, whether to accept null hypothesis or reject null hypothesis, and vice versa. All right. So let's now take an example on how to formulate hypotheses in a research. Look at this question. Examples. To test whether the mean score of an exam is greater than 80, our hypothesis can be written as this. Look at the question. Whether the mean score of an exam is greater than 80. So it means mean greater than 80 is our interest. That is what we are interested in. That is what we think should happen in this research. So that means mean, represented as mu, Greek letter mu here, greater than 80 will be in the alternate hypothesis. Whereas every other available, number or score between 0 to 100 will now be placed under null hypothesis. So look at the way it is written here. H0, column, H0 says mu, the mean, less or equals 80. This is done so that we can cover all available numbers. Look at the two of them now. The two hypotheses now. H1, mu greater than 80. H0, mu less or equal 80. The two of them have effectively covered all available scores in an exam from 0 to 100 marks. There's no number left out. I hope you can see that clearly. There's no number left out. That is the proper way to formulate an hypothesis. You must not leave any condition out mistakenly. So if null hypothesis says mu not equal to 80, and then it didn't say mu less than 80, but it didn't say not equal to, it means there will be a particular number that is left out. So that should not be. All right. So the next one is alternative. Mu greater than 80. Greater than 80 is from 81 to 100. And so that one is what we're interested in, and it's in the alternative. But mu less than 80, that is from 0 to 80. So all the available numbers have been captured like that. That's the formulation of a good hypothesis. Let's see the second one. To test whether the mean delivery time for a meat pie processing eatery is less than 15 minutes. Then how can we write the hypothesis? The hypothesis can be written this way. Less than 15 minutes, that's what we are testing for. That should be in the alternative hypothesis. But anything 15 minutes and above 15 minutes will be in the null hypothesis, that is opposing what we believe. So let's see it. H0 is equal to H0 mu greater or equal to 15. That is 15 minutes. Okay? And then alternative H1 mu less than 15 minutes. You could see that in this situation, all the available values have been covered from 0 to 15 and above 15. You see? Now that is the proper way to formulate this hypothesis. All right. So alternative hypothesis and null hypothesis, two of them work together to form complete set of statements on a research. Complete set of statements that we are going to, analyze and make a conclusion about. All right, let's see the third one. To test whether the mean annual pay for doctors differ from 50 million naira, our hypothesis will be written as this. Let's see. Mean annual pay for doctors differs. Look at the term, differs. We want to test whether it differs from, that is not equal to 50 million. So that is what we are interested in. We are interested in not equal to 50 million. That should be in alternative hypothesis. But anything, less than 50 million, anything 50 million within the null hypothesis, not equal. We can be less than 50 million or greater than 50 million. That is not equal. But 50 million will now be in the middle, and that will be in the null hypothesis. See our null hypothesis here now. H naught. H naught says mu equals 50 million. That is the mean annual pay for doctors. Mu equals 50 million. Now, H1, mu not equals 50 million. Mu not equals 50 million. This is very interesting. Excuse me. The mu equals 50 million. That is null hypothesis. Mu not equals to 50 million is what we're interested in. Either it is less than 50 million or greater than 50 million, but it is not equals 50 million. Now, if you mistakenly say greater than 50 million here, then it means less than 50 million will be left out since it is not in the null hypothesis. Or if you say mu, no, less than 50 million, and then you leave it like that. If you leave it like that, then mu greater than 50 million will be left out. Will be left out, and that's a mistake in the research. Hypothesis must not be formulated in that manner. The two hypotheses must be all-encompassing, cover all available, spaces, all available statements or figures in the research. So that is that. All right. So the two of them must be complementary. The H0 and H1 must be complementary, covering all outcomes, and then they have equal parts, of the equation. Then, like I've explained, our interest in research, or the matter that we are testing, is always placed as H1, is always in the alternative hypothesis. Now, when we want to make decisions, two possible decisions, can be made. One, when you have carried out your inferential statistics and you are going to make a conclusion, you check your tables. The value you got from the table, you compare with the value you got in calculation, then you make a decision. Now, how do we make decision? One, you will always reject H0 when you have sufficient evidence. When you reject H0, it means you are going to accept alternative hypothesis, H1. Or do not reject H0 based on the statistical value that you have, and then reject the alternative hypothesis. Those are the two conditions that are possible. Those are the two conditions possible in making conclusion. Now, when you make conclusion, you must be careful not to make your conclusion wrongly. Because when you make your conclusion wrongly, if you should accept H0 and you reject H0, then you have made error in the research. You have made an error. Likewise, if you should reject H0 and then you accept it, you have made error in the research. So we must try as much as possible in the research to look at the data we have and make a correct conclusion. If you reject H0 when H0 is actually true, then we have an error called type 1 error. Type 1 error. On the other hand, if you accept the null hypothesis when it's actually false, when it should be rejected, we have made an error called type B error or type 2 error. Now, alpha is actually the probability that type 1 error of a type 1 error occurring, and that is called a level of significance that we have mentioned above. Alpha is the probability that we are going to have a type 1 error. That is, if you reject H0 when it is actually true, the probability that that one will happen is the alpha level or level of the significance. And beta is the probability that we are going to have a type 2 error. And beta, probability of a type 2 error, which is that we actually accept non-hypothesis when it's actually false. So that is type 2 error. Now, the power of a test refers to the probability that we have correctly rejected H0, and that can be calculated as 1 minus beta. 1 minus beta. If you correctly rejected H0 when it's supposed to be rejected, then that's the power of the test, and that is 1 minus beta. So this is the few things we want to discuss about formulation of hypothesis, and I think you have actually enjoyed it. So please ask your question. You can send me chats in the chat box. I will respond to your questions so that we can actually know what is not clear in this lecture. So thanks for joining and thanks for being there. Thank you very much. So we'll see you later.